I'm Ann Sigmund,
And I'm Abby Torno.
and our proposal questions how architecture can bridge a gap between biology and technology. Our design synthesis is a space that utilizes computation and fabrication to construct sustainable and efficient building skins. At the simplest level, an architectural building skin is responsible for providing thermal comfort and protection to its users. But what if a building skin was able to provide for more of the user's needs? Our site is located in Des Moines, Iowa at a historic Union Depot in the East Village. Throughout Des Moines, we see a range of building skins from the gold-gilded dome at the Capitol to the copper glass at the Chipperfield Library. These important buildings have become architectural icons for the city. But what if we widen the range of building skins throughout Des Moines and use today's knowledge of computation, technology, and science to maximize efficiencies and sustainable practices? Our architectural proposal allows a space for fabrication and testing of future building materials.
The existing historic Union Depot will remain on the site, and our new addition will provide a space for building materials to be fabricated and studied. Our building houses robotics labs, education classrooms, and a public cafe. The site has direct access to the old railway, which the city is converting into a bike path. This allows good public exposure to the pavilion space. We have organized our building to maximize our surface area on the south facade. This is where we have designed our own building skin. This will be marked as the first adaptive facade in Des Moines. The south facade is important because of its access to sun throughout the day. The orientation of our building allows all of our servant spaces such as mechanical, bathrooms, and circulation to be to the north of the site. This allowed us to utilize the south of the massing for robotics labs that can be viewed from the exterior. Our circulation runs in between the served and servant spaces. The public has access to a majority of the first and second floor, but is able to see into the robotics labs. The third floor is private space reserved for the research team and special events.
Our main entrance is on the east of our building next to the historic Union Depot. This is where our lobby and shop are located. This also includes a storefront of the existing depot that houses administrative offices. Further into the center of the building is our public cafe and dining area, which has great access to the outdoor pavilion. The outdoor pavilion is directly connected to the bike path and can act as a rest stop for people riding through. All visitors have access to the public cafe and can use the outdoor seating. Our lower level houses our first robotics lab that uses KUKA robots for fabrication. The level is 5 feet below grade, but utilizes a double height space for clearance of the KUKA robots. The public has access to views into the lab because of the accessible ramp running along the curtain wall. There will be a variety of research testing and fabrication occurring in these labs. Researchers will study topics such as cell growth, chemical reactions, and ecosystems. The product of the research will be innovative building materials that mimic biological processes fabricated by current technology. The ramp also allows views to the fabrication lab on the second floor and access to the education classrooms. These classrooms allow a traditional space for the public to learn about the research occurring in the labs. The third floor has offices for the research team, an outdoor patio for events, and the remainder of our robotics labs. The materials are delivered and enter the lab space on the west. We have a freight elevator to move the materials to all floors. The third floor is where material testing takes place, looking at structural, thermal, and weathering properties. We have control rooms that are able to manipulate the variables of the space to test the properties of new building materials. Compression testing evaluates the structural integrity of materials, such as a masonry block grown from bacteria. Infrared testing evaluates thermal properties, and weathering testing exposes materials to the natural elements.
Our structure allows us to have an open floor plan for our lab space, pushing all columns to the exterior. We are utilizing trusses to convey a light and open environment. We have placed thermal chimneys in the center of our building to passively cool our cafe, dining, and classrooms. We are utilizing a green roof to filter the rainwater and allow it to run down the cavity between our building and facade into an on-site cistern. The south facade is constructed from soft robotics PV arrays. The facade skin attaches at the curtain wall mullions. We are utilizing custom brackets to vary the distance of the modules in order to create a fluid skin wrapping our building. In order to construct our building skin, we have broken up the south facade into varying module sizes. The diagram shows the module dimensions and where they are located on the facade. We are using zinc cladding as a building skin in place where our facade is absent to contrast with the existing depot terracotta brick. The PV soft robotics will move orientation to follow the sun path. The skin mimics heliotrophism, the motion of plant parts in response to the direction of the sun. Plants use this process to maximize photosynthesis for energy, and we are utilizing a similar process to produce renewable energy.
The skin is able to diffuse direct daylighting into large spaces like our labs and atrium. Our project is meant to be a space that welcomes the public to learn about current research being conducted using today's technology and knowledge of sustainable architecture.
The exterior of the building showcases how engineering new facade systems can create new architectural icons for the city. The glowing interior highlights the research behind these innovations. As our project is the first adaptive facade in Des Moines, it is a catalyst for future building skins. As architectural practices change, we should be prioritizing implementing efficient and sustainable systems that positively impact users. On top of providing thermal comfort and protection, architecture can aid a user's well-being through connecting them with the natural processes such as solar harvesting. Synthesis represents a space where these processes can be discovered at the intersection of biology and technology.